Welcome to this last video in the lecture series. We're now going to do step 10 in the workflow document, which is determine the water surface elevation, and this is strictly for visualization purposes. So if we look at a couple of videos that have been generated, this one first. So let me start it up here. So we see here we can animate the response in a given wave, period and heading, and this is a 0 degree heading case. And we can, and sometimes it's useful, oftentimes it's useful to be able to see the water surface elevation as well as to just see the structural response. And so that's what we have here. And the other one, this is showing 0 degrees, and then I also have here the one for 45 degrees. And you can see that we're showing the water surface elevation as well as the structure. So let me stop this for a minute and maybe come back to, well, it's not going to make much difference, but you can see that we need a mesh here of the water surface panels on the water surface to do this visualization. So we need to create that, and that's really the only step in this process that's of any complexity. So this is a relatively simple structure. I can hardly get any simpler. And to generate the mesh, you can see we have a rectangle here in the front, a rectangle here on the side, and a rectangle on the other side. So there's basically 4 rectangles, and so it's very easy to mesh in Hydran with this kind of geometry. Now, if the geometry is more complicated, you may want to use an outside program to generate the mesh of the fluid panels. So let's look at the input file here. So we clearly need to read the Hydro database, and then we need to generate the surface nodes and panels. So this generates the surface nodes. Actually, I'm just generating those 4 rectangles, and then I'm going to subdivide them to get the final mesh. And so it's fairly straightforward. The only trick is you shouldn't have, notice I've got 5.01 here for Y and 50.01 here for X. So they're offset a little bit from the structure. You don't want one of these surface panel nodes to be coincident with the structural node. Otherwise, it's going to be the structural panel node. Otherwise, it's going to cause some problems. So it's not a big deal, but you just need to make sure you do that. This command just kind of cleans up those input values if necessary. And then again, I generated the 4 surface panels, the big ones, and then I subdivided them here. The next command actually does the work, hide surface elevation. So if we go to the help file, then it has all the input data information on that command. And there are 3 wave potentials. There's the incoming wave potential, the diffraction potential, and the radiation potential. And you can include or not include any combination of these 3. So in this case, the default is to include them all, and so that's what we're doing. You need to tell it where the diffraction potential and the radiation potential are and what file they're in. And to get these, you needed to use the -source option on the hide analysis command. Okay, once that's done, then to export it to the graphics, you just use the hide export graphics command. And let me expand this a little bit. You need to tell it to include the free surface, and you need to give it a file name to save it to. In this case, I'm looking at frequency 47 in the list of frequencies that we had, which is actually coincides with the 8-second frequency or period. And in this case, angle 1, which is 0 degree wave heading, and angle 3 in this case, which is the 45 degree wave angle. All right, so let's see here. We can just run this guy. It's going to be this runs very quickly because there's not too much computation involved in this. So I'm going to call this surf. I'll just leave it there. Type in file in. And you can see that it's going through, and it's going through each frequency and processing it. And it's done. So it has created these files here, these .msh files, which can be imported into a graphics program to do the plotting. I should have stated that I'm choosing to create 80 steps per cycle. So it's a pretty good frequency for the to get a relatively smooth animation. Okay, that's it. What program you imported into, Gmash or something like that? Any program that'll read the .msh files. That concludes the lecture series